Hello students and welcome to Exponents Part 3. In this lesson we will continue learning about exponents and use our skills of evaluating them to learn how to simplify an exponential form. Remember, an exponential form is simplified if there are no zero exponents and no negative exponents. We have already looked at how to simplify these two types. We know that zero exponents are equal to 1, and we know that negative exponents in the numerator or denominator can become positive exponents if moved to the opposite. Today we're going to look at product powers when we have multiplicative properties. So when we see that the base appears more than once in a product, we know it's not simplified. We're going to learn how to simplify that. In the fourth lesson, we'll learn how to simplify the same base in a quotient. In this lesson, we will learn how to fix powers raised to powers and products raised to powers. Our last two will be looked at in lesson 4. As you already know, this year we are learning how to simplify numeric and algebraic exponential forms. Today we are going to learn 3 more rules for simplifying numeric and algebraic exponential forms. Today's rules could be classified as multiplicative rules. Here are the names of the 3 multiplicative rules that we are going to look at. The product of powers. When we multiply 2 powers with the same base. The powers of powers, when a base is raised to 2 exponents. And also the power of a product, when a multiplication problem is to a power. Let's first start with the product of powers property. This product property is used when we multiply 2 powers. Here's an example. If we have 3 squared times 3 to the 4th, this is an example of the product of powers property because we're multiplying 2 powers with the same base. If you think about what this really means, 3 squared is the same as 3 times 3. And 3 to the 4th, when we multiply it, is the same as 3 times 3 times 3 times 3. If you multiply 3 by itself 6 times, that's the same as writing 3 to the 6th. So this rule says if you have the product of 2 powers with the same base, it's always equal to the same base number, see how the base number stayed the same, the 3, raised to the sum, which means to add the exponents. 3 squared times 3 to the 4th is always going to be equal to 3 to the 6th. A shortcut is to keep the base the same, add the exponents. 2 plus 4 is 6. Algebraically, this rule can be represented this way. If you have some base number to a power times the same base number to a power, it will always equal the same base to the sum of the exponents. Let's practice. I've wrote the rule down here so that we can use this to help us. Remember, the base to a power times the same base to a different power is equal to the base number to the sum of the powers. So if we have 2 to the 5th power times 2 to the 6th power, it's going to be equal to the same base number raised to the sum of the exponents. So 5 plus 6 makes 11. 2 to the 5th times 2 to the 6th is equal to 2 to the 11th power. Now, you can have the same base more than once. Do you see how these two have the same base? We can combine them. 4 squared times 4 to the 5th is going to be equal to 4 to the 7th power. All we did was add the exponents. 2 plus 5 makes 7. Now, the other two terms have the same base as well. 3 to the negative 12th power times 3 to the 5th power. So we're going to have times the same base, which is 3, and we'll have to add the exponents. Negative 12 plus 5. If you owe 12 and you have 5, you get negative 7. Because negative 12 plus 5 is negative 7. Now, we have simplified the power of this we have simplified the product of two powers. But if you look at our simplified expression, it's not truly simplified because it has a negative exponent. The 4 has a positive exponent, so it will stay in the numerator, but the 3, since it has a negative exponent in the numerator, will have to move to the denominator. So we'll have 3 to the 7th power. So this expression simplified is 4 to the 7th over 3 to the 7th. We combined two properties there. All right, look at our new expression. A to the 4th times b to the negative 5th times a to the negative 2. Do you see how we have the product of two powers with the same base? We can combine them. A to the 4th times a to the negative 2 will make a squared because 4 plus negative 2 makes 2. Bring the b to the negative 5th along. Now you notice we have two exponents, but this one is a negative exponent, so we need to move it from the numerator to the denominator to simplify it. A squared will remain in the numerator, b to the 5th will be in the denominator. Since it was negative in the numerator, it becomes positive in the denominator. This expression is the same as a squared over b to the 5th. This rule also works if you have the same base more than twice. If you have the same base more than twice, just add all the exponents for that base. So we have y squared times y, which is the same as y to the first power, you can write that in on your sheet, times y to the negative 4th. So we know the base number will be the same, and we have to add all the exponents. 2 plus 1 is 3. 3 plus negative 4 is negative 1. If you have 3 and you owe 4, then you owe 1. Now this is more simplified than it was to begin with. However, we have to simplify it further because now we have a negative exponent. So we'll write 1 over y, or y to the first. This is your simplified expression. It works for numeric expressions as well. Here we have the same base twice. 7 to the 6th times 7 to the 4th. Base number stays the same, add the exponents, which makes 10. And we'll just leave times 3 on the end because these bases do not match. This is a simplified expression. We have 3 to the negative 3 times 5 to the 8th times 3 squared times 5 to the negative 8. Let's combine the same bases by adding their exponents. We have 3 to the negative 3rd times 3 squared. So we have the same base number, which is 3. Negative 3 plus 2 makes negative 1. We have the same basis here. 5 to the 8th times 5 to the negative 8. So we'll have 5, and we'll have to add the exponents. 8 plus negative 8 makes 0. So we have 3 to the negative 1, 5 to the 0. Remember, 5 to the 0 power is equal to 1. So we don't need to write that because 1 times anything is just itself. So we have 3 to the negative 1. That has a negative exponent, so we're going to have to move it to the denominator to get 1 over 3 to the first, or just 3. So this expression is equal to 1 over 3, or 1/3. M times n to the negative 4, m to the 4th. Remember, if you have a variable, it still has an exponent of 1. We can combine these two because they have the same base. So m to the 1st times m to the 4th makes m to the 5th. N to the negative 4. M to the 5th will stay on top because it has a positive exponent. N will move to the bottom with a positive exponent. Since it was negative in the numerator, it's positive in the denominator. M to the 5th, n to the 4th is your simplified expression. X to the negative 1 times x to the negative 3rd times negative 2 times x to the negative 4. We have 4 parts of products all with the same base. This x has an exponent of 1. I like to write it in just to remind myself. So let's add them together. Negative 1 plus negative 3 makes negative 4, plus 1 makes negative 3, plus negative 4 makes negative 7. So we get x to the negative 7 times negative 2. Now, negative 2 has an exponent of 1. If you don't see an exponent, it's an exponent of 1. So this negative 2 is going to remain in the numerator, but the x to the negative 7 needs to move to the denominator and become positive so that we no longer have negative exponents. So this expression is the same as negative 2 over x to the 7th. Now, let's look at the second property, the powers of powers property. This property says a power raised to another power equals that base raised to the product, which means to multiply the exponents. This one is used when you have a power raised to a power. Let's look at an example. If we have 4 cubed to the second power, we see powers of powers because this base has 2 exponents acting upon it. Now think about what a square means. A square means to multiply by itself. So this literally means 4 to the third power twice. Well, what does 4 to the third power mean? 4 to the third power means 4 times 4 times 4. And this 4 to the third power means 4 times 4 times 4. So how many times are we really multiplying 4? 6 times. And the shortcut is keep the base number the same, multiply the exponents. 3 times 2 is 6. Algebraically, we could say that it looks like a base number to an exponent to another exponent, and it will always equal that same base to the product of the exponents multiplied together. So let's look at some examples. Here's our rule to help us. We have 7 to the 4th to the third power. Since we have a power of a power, we will find the product of those exponents. So we'll have 7 to the 4 times 3, which is 12. The 7 to the 4th to the third power is equal to 7 to the 12th power. We have 3 to the 6th to the 0 power. Remember, our rule says we have to multiply the exponents if we have a power of a power. So 6 times 0 is 0, so we get 3 to the 0 power. This is not a simplified expression because now we have a 0 exponent. We know that any number to the 0 power is 1. So this expression, 3 to the 6th to the 0 power, is equal to 1. Let's try 5 to the negative third power squared. Since this is a power of powers, we have our rule that says we can multiply the exponents. The base number will stay the same, so we'll have a base of 5. Negative 3 times 2 is negative 6. Now, this is a more simplified version, but it's still not simplified because we have a negative exponent in the numerator. So we'll have to move that base of 5 to the denominator with a positive power. So we'll have 1 over 5 to the 6th power. You can combine this property with the last one that we did. Start with the powers of powers though. When you have powers of powers, do it first. So x squared to the negative 4 power is the same as x to the negative 8 power. Multiply 2 times negative 4 makes negative 8. Now, when you have the same base being multiplied, we need to add the exponents. So x to the negative 8 times x to the 5th is equal to x to the negative 3rd power. Since it has a negative exponent, we'll have to move it to the denominator, make it 1 over x cubed. That is your simplified expression. We will look at a few examples in part 2, and then we will look at the third rule.